Okay, hi everybody, I'm Kayla and I'm just going to be talking about my experience this summer. So this summer I was a field engineer for the UNAVCO Student Internship Program, or USIP. My objective was to learn about NODA GNSS stations, how the sites are designed and operated. And my background is material science engineering, so I have no background in like geography or geodesy. So my personal goal this summer was to learn more about geodesy, the tools we use for it, and what that data means for us. So my method was basically just to take it week by week, learning something new, focusing on a different topic, and I had fieldwork interspersed between. So my first week was enclosure build outs, built a few enclosures to learn like what comprises of them and the general placement of each component. So in this picture, we've got back panel. I learned how to punch out holes for the Huber sooner, lightning and EMP protection, wires, solar block terminal, and how to prepare like the extra bag for in-site installation, like battery jumpers and stuff like that. I took this week to become familiar with the purpose of the GNSS stations. So how we use it for GPS, earthquake detection and early warning systems, groundwater levels, volcanic eruptions, stuff like that. This week, I also learned how to crimp and solder the jumpers that we use for batteries. And I got to do some arc welding, which was really fun. My second week was focused on back panel builds. So we got a couple back panels in from the field, and I was able to upgrade the old terminals for new ones. So in this picture, you can see we got terminals for load, negative, solar, battery. Learned what all of those do, learned about the breakers to stop surges, and our charge controllers that we wired up. And you've got a closer look at those Huber Sooners and the wires. And I also configured some receivers with their serial numbers and making sure that they were tracking satellites for the following week in Utah with fieldwork. So my third week I spent in Utah with my mentor, Sarah. We visited 5 stations. That top picture is P121. Over the course of the week, we did some radio repairs, some GNSS upgrades, which for the time being just meant that I was replacing the old antennas with a new one from the warehouse. What else? Oh, and we did some battery swaps with standard 4 battery enclosures. And in the bottom picture, you can see this is an old back panel. So I swapped that one out for one of the new ones that I made while in the warehouse. At the end of the week, we emptied out a storage container in Salt Lake City. And while we were in Salt Lake City, I got to visit the Great Salt Lake. It was very beautiful. That's like a pile of salt, but there were a ton of brine flies and it stunk to high heaven. So now I can say that I've been there and seen it, but I never need to go there again. My fourth week was doing antenna LNA swaps. LNA stands for low noise amplifier. Basically just means our antenna can take a low powered signal and amplify it without increasing the noise too much. So as you can see in the left photo, I swapped out these simple L-shaped connectors to the S-wave connectors in the right photo. And these are just changing the choke ring gaskets, basically. This allows us to go from GPS only to GNSS. So GPS is just a standard US constellation, but GNSS tracks every constellation in the world. So ones from Europe, Russia, China, all that. My fifth week was working on meteorological packs, or MET packs for short. Configured the MET packs for use in the field. So as you can see in the right photo, I've got some red and black batteries, or red and black wires for power connection. And I configured the MET packs so that they showed, I can't remember the name right now. I configured the MET packs and made sure that they were tracking location and wind. Oh, and measuring barometric pressure in bars instead of mercury, I think. My sixth week was general work and Mount St. Helens prep. So I continued with METPAC cable making and configuration, prepared new Focus charge controllers, which you can see in this picture. I drilled larger holes for use in our current back panel configuration. And then started getting ready for Mount St. Helens and prepared some jumper cables to take with me there. And these are some pictures. The top one is me at Northwest Dome. We had to fly in a helicopter to get to all of our sites. It was an amazing experience. We replaced a total of 156, like the 70-pound car batteries, and replaced a bunch of old back panels and radios and antennas. So in the bottom picture, you can see Chad, myself, Ken, and Leah. Bottom right, Ken is in the enclosure, also on Northwest Dome in his little red shirt. Some more sites that we went to, that's Leah and Andre at the GOAT station. Some batteries that I had to replace at one of the sites. And I also broke my phone. It was still working technically, but I couldn't see anything. And luckily I was able to type because I remembered exactly where the keyboard was for a week. So that was interesting. My 8th week was upgrading Polar RX 5 receivers to the 5.40 patch firmware, and then completed a couple more back panels with those new Focus charge controllers. My 9th week was a full station build on the UNAVCO roof. Summer and check and see if something went wrong in the field, how that would affect our data and our enclosure. So you can see I've got a battery, a back panel, and a receiver. Everything here I wired and configured or made myself. In the middle picture, we've got a MET pack in the solar panel. And to the right, we've got a regular antenna GNSS tracking.
Okay, I thought it was just me because I was in a spot with not great Wi-Fi. But apparently not. Can you all hear me right now?
Yes.
Okay. Kayla, are you still here? Because it might have been a Wi-Fi issue.
Anika, I'm wondering if it might be here in the office. I just had to switch over to the visitor wireless.
Okay.
I'll
Kayla's not
I'll run over to her cube and see if she's there.
Yeah, let's do that. Oh, there she is.
Okay, hello, sorry about that. It looks like my Wi-Fi just decided to cut out suddenly.
Yeah, Annie said something. Wi-Fi at the office. Not
Yeah.
great.
Okay, sorry about that.
That's okay.
Where did we leave off? Did you get when I talked about our constellations here?
I didn't hear this slide at all.
Okay.
No, this one. Yeah.
Okay. Did we end off here? Did I talk about the pack solar panel?
Yes, we heard most of the slide. Yeah.
Okay. So I let it run for a full GPS cycle day. Our battery load and solar were exactly what we would expect for the voltage on those. And I used TechQC to pull satellite data off the receiver. So here it looks like a lot of information, but it's basically just telling us what satellites we're tracking and if they look good or not. So you can see we've got our different constellations: GPS, GLONASS, SBAS, and Galileo. There. So Tuesday, I replaced the battery with one that wouldn't charge to simulate if we had battery failure in the field. And basically everything just went offline. I was kind of hoping solar would be enough to charge everything, but learned the hard way: if your battery is gone, station's down. So you can see here, we didn't start tracking again until Wednesday around 10:20 when I plugged the battery back in. Wednesday morning, placed that battery, flipped the solar circuit to simulate a broken solar panel or a charge controller that wouldn't charge the battery with solar power anymore. our initial drop off is pretty big, but over the course of the day, every hour, we only lost about 0.03 volts. This was just with a standard 12-volt battery, just a single one, which would last us about 17 days straight. So in comparison to a 4, 8, or even 24 battery enclosure, we would be with power for a long time. 4 p.m., I put solar back and unplugged our med pack. What we would expect to see is just lost data. We get 3 pages instead of 7 for a full GPS day cycle. And you can see that it measures pressure, temperature, humidity, wind, rain, etc. Thursday, I wanted to see what would happen if we had a loose antenna connector. So around 10:30, I unplugged our connector. You can see these little carrots down here, which just indicates that we've lost satellite tracking, essentially. And if you go straight up, you can see their L's, which also correspond to a lost or incomplete signal. So that's exactly what we would expect. I let the connector be loose and then plugged it fully back in here. In the blue, you can see that we don't see a big increase in how many satellites we're tracking. So even a loose connector is going to be good out in the field. Then I let it run over the weekend and everything was completely normal. So if you mess with an enclosure and just put it back the way you found it, it will be good. So this summer, I learned about each component in a permanent GNSS station, how to upgrade, troubleshoot, and repair each part. And I gained enough experience to set up and maintain my own station. I learned to retrieve and interpret data from those stations. And I learned a lot about geodesy from all of my mentors and the grad students and even my peers, which was amazing. This summer was a great hands-on experience, and I definitely have an interest in pursuing a career in geodesy. I'd like to give a very special thank you to my mentor, Sarah and Summer. Thank you to the Mount St. Helens team for making it just an amazing experience. Everyone I met in the office, thank you to my fellow interns, and a special thanks to NAVCO for making this all possible.
Thank you. That was great. Glenn, you have a question.
Sorry, taking a second to unmute and bring my video on. Again, more of a comment than a question. A wonderful presentation, and I want to applaud the two mentors, Sarah and Summer, for creating such a structured learning environment. This should be the template for all of our new staff within GI going forward.
Yes, they were absolutely amazing mentors this summer. And I definitely appreciate like all of their knowledge and their kindness, and just the structure was amazing for this summer. Learning, like taking it step by step, was super beneficial to learning. And there was so much to learn, like learning about the different, like even just different acronyms that we use in the field, but taking it week by week was super helpful with that.
Has this made you think of like other classes and things that you could do at school that would supplement what you did this summer? Or are you?
Yeah,
thinking-
definitely. One of the more exciting presentations that a grad student has was about groundwater. So going forward, I think I would be very interested in learning more about that.
Great.
I had a quick question. Hi, Kayla. Great presentation. Really appreciate how you compiled it all week by week. That was a great idea. Was there any challenge, or was there anything that you found difficult that you really felt that you found difficult at the beginning of the week, and then by the end of the week you felt like you mastered that or had a better comprehension of that task?
Yeah, I think in the beginning it was really overwhelming just because I knew that there were going to be so many different parts of like everything to come together and work together. So getting the terminology right, getting the parts right, knowing like every single piece that went into a station. But like I said, taking it week by week and like actually getting my hands on every single part definitely helped with that.
Awesome.
Okay, thank you, Kayla.
Thank you.